Thank you very much. Well, my name's Ian Quest. I'm one of the directors of Quick Release. I'm going to hand you to our COO, Nick, to give you all the clever and insightful stuff in a minute. But I wanted to give a bit of context around Quick Release, who we are, what it is we're trying to do, and a little bit about how we're going about doing that. So, first of all, 3 facts and an opportunity. The first fact: there's never before been more demand for products to be developed and created and brought to market faster. And it's no longer just a profit motive. There are some really important problems out there that we need to go and solve. The second fact is that engineers who are working on these, on average, are spending only 1/3 of their time actually working on the products, engineering them. That's a crime. 2/3 of their time is lost for roughly half and half, 2 reasons. The first is extracting and inputting and hunting for information, data and information on their program. The second one is attending meetings. And those meetings, whilst some of them clearly it has to happen, there's some communication that needs to go on, typically half of those meetings are spent establishing what the status is and not talking about what the team are going to do to address those problems or to push the program forward. And the third fact is that whilst we've got some incredible systems, incredible technologies out there, and things have come on so much in the last few years, and we're seeing so many of those tools around, neither that nor the application of lots of available low-cost resource to take away admin tasks from engineers have actually solved this problem. There's something more that needs fixing. So, and our belief is that having good quality data deserves the same passion, the same professionalism, the same focus, the same investment as the passion around the product. We've got lots of professionalism, lots of passion around product. We need the same about having good quality data. It's not good enough to say, oh, well, if some of those fields are not quite right, that's not working. It's just not good enough. It's not going to support any of these technologies that we're developing. So this is kind of what we get promised by the system. So the idea that from CAD to kit, you've got this beautiful shiny pipework that gets all of the information there cleanly and crisply and accurately and clearly. And were it the system alone, that would absolutely be the case. But when you introduce complexity, you introduce variation, you introduce many different suppliers and different people working on the same program, and you introduce human beings, and it's great to hear how much of a topic that's been throughout this conference. Once you introduce that, it looks a little bit more like this. So with data leaking out, with inaccuracies entering the system, lots of losses. And that affects us broadly in 3 ways. So time losses on the program, overspends and consequential costs, and actually some of those issues actually get out into the market and into the product, and they're probably the most concerning of all. So program time losses, perhaps we order all our parts on a given date for the program, which works for some parts. It's too late for others, and it's too soon for others, which will then suffer change and churn before it comes out. So we end up with late parts and the program's late. Overspends. When we hit those gateways and we're not quite there, we'll just put a bit more resource on it. We'll get some more engineers, that will fix it. Or we have to air freight parts in, or we have to get some prototype tooling built because the production tooling wasn't quite ready in time. And then those that leak out into the market, obviously potential recalls, potential issues, some that you'd rather not think about. So those problems, we have made that our mission to tackle those. So we believe that product data is program lifeblood. It's a bit like trying to plant seeds in fertile soil. It's not going to happen if the data isn't right. If we haven't got it to a certain level of accuracy, that we can report on it, that we can give people useful information to do their work. So we've made it our mission to address these things with, and I guess essentially try and create a profession around it. So how do we go about doing it? Well, I've simplified this down into 3 very, very basic steps, but the first one is about getting that data correct. So we will engage with our clients and this all starts in potentially in a very manual way, but if the data isn't right, we can't build on it, we can't report on it, we can't expect people to take it seriously if they see that report, they see there's an error, and it just undermines the whole thing. So the first thing is to get in there and get the data right. There are some automated ways that we can do that, and there's lots of tools we can use to help check for logical checks. Is it in the right format? Does it align to this other system? Is the timing right? But there is some stuff where we need professional people who understand the systems, who understand the data and the hardware, sit down, independent to the engineer, and check with the engineer that what they've got in the systems is aligned to the engineering intent and the overall product intent as well. And that takes time and it takes effort, but it pays huge dividends. The second thing is we've got to get beyond just reporting. The classic automotive night letter, I'm sure a number of you are aware of that, a program summary report which gets sent out at the end of each day to hundreds of people on the program. It's a flat report, everybody gets the same one, and about 10% of people actually read it. It's not what we need now. Every role has a different need for how they're going to consume the information and what they're going to do about it, and we need to align to those roles. And every individual actually wants something slightly different. The very data savvy recent graduate engineer has a different need for information than the very, very experienced guy who perhaps doesn't like engaging with the systems as much. And then the last thing is we often get engaged at peak times during programs, so when the pressure's really on. And so some of these things we need to do on the fly, we need to do tactically, we need to just get stuck in and roll our sleeves up. But we can't leave it like that. We can't have sticking plasters holding the thing together. So this is a process that needs to continue to be professionalized. And it's all underpinned by having a service level. If we can measure the quality of our data, we can monitor it and we can make sure it's being maintained. And that's the thing that we need to be focused on, not the cost of having a PDM department. So that's what we will focus on to make sure that we're always delivering that quality. So now I'm going to hand you to Nick, and I think Nick's going to talk about a specific aspect, one of the sort of services and tools that we've developed. But it's important to know that has come from being on the ground doing this work. When QR started, it was just smart people making themselves responsible for data. It's built up a lot, the tools have developed, it's become a bit more sophisticated, hopefully, and it's got a long, long way still to go. But the grounding, the basis of it is we are the people that have been in there doing that, correcting that data, getting it right, liaising with the engineers, working alongside program directors. So the origins of this is very, very dirty and gritty. So I'll hand you to Nick.
Thanks, Ian. Good morning, everyone. So the story I'm here to tell you today starts in the basement of a West London coffee shop. And in this unexpectedly dark, cramped, sweaty, airless room, we had assembled 10 of our subject matter experts from across the business. And the topic at hand was about how you successfully plan the journey of a part from the digital to the physical. Each part has to be conceptualized, designed, engineered, tested, ordered, and delivered. And on complex products, which have many thousands of these parts, and in modern businesses with complex processes involving many stakeholders, it's really difficult to simultaneously coordinate all these part journeys. It's a challenge to get the visibility and to take actions early enough so you can actually make an impact. And so this concept of a plan for every part is sometimes called an ETRS, an engineering timing release schedule. But at Quick Release, we want to change that terminology. We want to start talking about a BTRS, a business timing release schedule. It's way more than engineering that needs to get involved. You need a whole cross-functional organization in order to successfully deliver these products. So Quick Release has done a lot of these kind of BTRS type projects, and we really want to pull together all our best practices and our experience and offer something to the market. And so today, I'm really excited to launch Chronos. Chronos, named after the Greek personification of time, is a tool and a set of processes that are going to help us deliver projects and programs on time and to better quality. And today, I'm going to talk a little bit about the development and the thoughts that we've put into developing it. So if we look out to the industry, when people do have some sort of formalized part-by-part planning process, they usually take one of three forms. Firstly, the most common that we see is spreadsheets. Now, don't get me wrong, there's a time and a place for spreadsheets. But when you're managing large amounts of complex data and calculations, drawing data from multiple sources, multiple users need to interact with it, using spreadsheets, you're really opening yourself up to a substantial risk of loss of data quality. They're also much harder to control. What's the latest version? Is it the one on SharePoint or the one that you emailed me? And also, they take a lot of admin effort to continually to maintain. We've seen entire roles dedicated just to maintaining these BTRS spreadsheets. Second most common is kind of individual part plans. So you have your project engineer, he's got his Microsoft project file, he's planned out all his steps, but it's entirely divorced from everyone else's parts. And it's really hard to get that overall program view in order to see where your critical path is. Or thirdly, some sort of generic project management software. But the problem is that these aren't really designed to track at a part-by-part level. They don't come with the specialist implementation support in order to work for a product development environment. So even when we go into businesses and we see that they do have some sort of part-by-part plan, we keep coming across the same graph again and again. You start with the kind of perfect plan that hits the deadline right on time. And this is just classic optimism bias, where we believe that negative things are less likely to happen to us. It's this kind of home run plan that is achievable as long as everything happens perfectly and on time. And sometimes these look reasonable and even feasible, but the reality is as soon as one thing goes wrong, the whole house of cards tumbles, and you end up with the dreaded hockey stick. Now, I'm sure many of you will have seen hockey stick graphs in the past, and in many places they've almost been accepted as a kind of acceptable failure. Now, there's three main features that make up these kind of hockey sticks. Firstly, the initial bottleneck. So we're not running to the initial planned run rate. And that's usually because we haven't had early enough visibility on what's going to hold us up so we can take action. And we don't often prepare our engineers very well for this. Imagine you're an engineer at a big automotive firm. OEMs typically take 3 to 5 years to take a product through from concept to delivery. And let's say there's a task you have to do once as part of that program. So at best, you do that task once every 3 years. Now, how confident are you, even for the most trivial task that might not have changed last time, that you'll be able to execute that on time and to quality without any assistance? Secondly, the cliff face. So this is the main feature. And this kind of rings of that focus on the gateway charge, that only looking at the final delivery date and not having that finger on the pulse of all the steps that get you up to it. And this is the period of huge management pressure, of long hours, of team burnout. And it's unhealthy, it's unsustainable, and it's really inefficient. And it also leads to the third feature, and that's lateness. Hockey sticks are often late. And it's this lateness that's really costly. We did a project last year working with a global OEM, and we were looking at one of their plants in the States. And so they were ramping up some new vehicle programs, and this graph shows the kind of planned ramp up for those vehicles. And the green is the plan, and the red is what they actually achieved. And this is at a plant where, for every minute that you've stopped the line, that's costing you tens of thousands of dollars. So we tried to investigate, well, what's causing all these lost units? And when we dug into the data, we found that the principal cause of that was late parts. 35% of those lost units were due to late parts. And even that doesn't tell the whole story. If you dig even deeper, on one of those programs, we found that the top 7 late parts accounted for 80% of the lost units. So it's not good enough to plan your programs at a macro level. You need this part-by-part level planning in order to find the critical path. Here's another example. This animation is pulled together from 200 different Excel spreadsheets which were tracking part data. And you'll see that the red dashed line is the original plan for releasing the parts. The red solid line is the updated plan as it gets updated day by day. And the green line is the actual curve that was achieved for releasing the parts. And you'll see this is that classic hockey stick in the green compared to the original kind of concave plan. You may also notice that the total number of parts that needed to be released was actually 10% higher than the original plan. And again, it's all about that early visibility, that early checking of your data, making sure your BOM quality is really good. There's another problem here. When we started looking at an individual part, so this is the wishbone assembly, which is a part in the suspension, and these are the steps that needed to go through in order to get that part from concept to delivery. Now, the BTRS that was being used was only actually tracking the middle 14% of those tasks. And so where you had slippages and issues happening up earlier, you didn't get visibility of that until you turn your ETRS on later on, which was then causing the lateness downstream. So you need these BTRS projects to cover as wide a scope as you can of that part lifecycle. Okay, let's take a step back. I think there are 4 main factors that influence really high-quality PDM or PLM. The first is high-quality people. You need motivated people, you need them well-trained, you need them doing the right jobs. And as Ian said, it's great to see that this conference has such a people-based focus. Once you've got the people, you need great processes. You need them optimized, you need them really high quality, and you need that people know how to use them. And then comes the system. Systems make those people and processes efficient. And then finally, you need data flowing through those processes and systems. And so we knew that when we started Project Chronos, that it was going to be way more than just a tool. We've all seen systems fail because they've been poorly implemented or poorly embedded. And you've probably also seen projects in which, because bad decisions are made off the back of bad data, people lose confidence in the process, and then people put in even worse quality data. And you just end up with that spiral down until the tool becomes totally obsolete. And so we put as much time into developing all the processes around Chronos as the tool itself. And we have our specialists go on site in order to help train, implement, embed, and deliver Chronos, whether that's kind of at-elbow support for the engineer or whether that's supporting directors level, making program level decisions. And again, as Ian said, this has come from a place of us getting in there and doing it, rolling our sleeves up, really understanding what makes this work. This wasn't a kind of theoretical exercise. Okay, so talking a bit more about the tool. When we started designing that, we knew we needed a feature set that was rich but really focused. Another kind of failure state we've seen is when these BTRS plan for every part tools try and do everything. Suddenly this tool is trying to be your master BOM and your attributes tracker and your stock tracker. At its core, this is a planning and reporting tool. And so we've worked really closely with our users to build the feature set around those principles. Secondly, we know we needed it to be configurable. What we didn't want to end up with was forked versions of the code going into different clients. We've got one version of the code base, and we pushed a lot of the configuration and customization down to be set up in the tool itself. Also, we don't necessarily think you need one system to store all your data. Nowadays, with APIs and RPA techniques, you can move data to and from systems pretty easily. And so rather than talking about a single source of truth, we talk about a single source of each truth. So really understanding for each piece of data, where's that mastered, in which system is that piece of data captured? And so we're now building connectors into Chronos that can pull information from common PLM and ERP systems in order to then do this planning. And finally, it needs to be live. There's nothing worse than sitting in a meeting being chastised for not doing something when you have done it, but just the report is out of date. And so we built this web platform that allows you to see the latest status, and we can deploy that either on cloud or on premises. So let's return to our hockey stick graph. And we said that one of the kind of key reasons this happens is because of too much focus on the end goal. And so when we implement Chronos, we work with our clients to understand all the stages, all the steps that take you from that part to go from conceptual to delivery. And we really understand and map that out. And so let's take an individual part here. So we understand when the final delivery date is for that part. We can then say, okay, what's the lead time on the stage that comes just before that? And from that, we can then work out when that's required. And then we go the stage before that, and the stage before that, and the stage before that. And then we know the exact required by date for every single stage of the process. And this is based on some pretty basic project management principles. But it takes real experts to go in there and validate that all this data is good, that you're basing then these plans and these requirements off. We have some smart tools as well that some of our consultants use, which use historical lead time data in order to predict and validate future lead time data. What we're trying to avoid is that situation we once saw where an engineering team worked all over the weekend to release a sheet metal part, only for the engineer to key in 2 rather than 22 into the lead time field. It wasn't validated, so the part was ordered 20 weeks late, and of course by that point it's totally unrecoverable for the build. Not only do we do this kind of right to left planning, but the Chronos system also does left to right planning. So when we start getting some actuals, we use those lead times to then plan out each further stage. And the difference between when the stage is planned and when the stage is required by gives us how late that stage is. And then we use some simple red, amber, green to kind of visualize that. There's also some other features where when we start getting commitment dates in for particular stages, they go into the tool, because the tool is constantly live planning everything updates, and you can see the latest status. So it's great if you've got all this data and you're doing all these calculations, but it's then important to do something with it, and that's where reporting is really, really important. And again, when we started working on this tool, we knew we had lots of different audiences that were interested in this data. You've got engineers and coordinators. They need to know, well, when should I plan to release my parts? What should I be working on now? What should I be working on next? You've got management teams saying, well, which parts are actually going to be late? What do I need to do in order to resolve those? Which teams are doing well? Who needs more support? How performant is the process overall? What are the key metrics? Or if you've got departments that are working across the bill of material, what's awaiting for their approval? What's in the pipeline? And what's the priority we're working on? Again, as Ian said, having that kind of single night letter that goes out to everybody is just going to be ignored. One-size-fits-all reporting doesn't work. You need to tailor it for the person that's going to be consuming that information. And even when you do start tailoring, high-quality reporting relies on Firstly, you need high quality and timely data, or at least a measure of the maturity of that data. I'd much rather you tell me that this part has a 16-week lead time with a 50% confidence than just to put any number in the box in order to allow the system to continue. Secondly, you need an agreement for the purpose and the use of that reporting. If you're just making graphs for the sake of it, you're doing something wrong. You've always got to think about what's the action that I'm trying to drive from doing this report. And lastly, clarity on how that report fits into the overall goals. If you've got multiple teams, each chasing their set of metrics, but they don't then summarize to the overall objectives, then again, that's going to be a problem. So in Chronos, we've created some kind of role and user-specific data views. Whether you're an engineer who owns a set of parts, or maybe you're a department that has to approve everything across the entire bill of material and so are interested in a stage, we cut the data depending on who the audience is. We have missing data reports. Again, that data quality thing is so key, and you need to be able to very quickly point people at where data is missing. And interactive charting. People consume data in different ways. We want them to be able to customize the way the data is shown to them so it means something. And prioritize to-do lists and automated meeting agendas. Because the tool now gives you the lateness at every single stage, you can prioritize things. You can make sure that everyone is always working on the latest thing first. And finally, notifications. What we don't want to happen is that one stage finishes and the next person doesn't know that they're meant to start that task. So we can provide automated notifications. Okay, I'd like to take through just 3 quick case studies that show some kind of different benefits of using this plan for every part approach. The first is with a German auto EV startup that we're working with. And here's a quote from their program director. So, we knew that the program was late, but Chronos helped us with the facts by how late it was and aided in key decision-making with the senior management. So we had a team go on site with them to clarify what the bill of material was, what all the stages were, populate all that lead time data, because they knew that they weren't going to be on time, but they had no real way of replanning what they were doing because they had no data behind it. So this tool gave them that clarity in order to then look at when they were actually going to be ready to do these builds. Secondly, a US auto EV challenger, they previously had a spreadsheet-based BTRS system, but it was taking 70 hours a week of someone's time just to kind of maintain and pull together this report. So now that Chronos is in there, that 1.75 people are now spending their time actually working with engineers in order to prove the quality of that data. And lastly, a UK aerospace manufacturer. We're still fairly early on in this implementation, but already kind of going through this process of working with us to plan out all the stages and get those lead times in has found kind of key gaps in their processes that they're able to address before they start actually running at it. So, my top BTRS plan for every part tips. Firstly, people, process, and system. You've got to invest equally in all 3. Whether you're still using spreadsheets or you're looking to move to more of a system like Chronos, you need to make sure that it's trained out, that people understand how to use it, and more importantly, why they're using it. Secondly, sounds obvious, but get the data right. Managing data is a specialism in its own right. You need to train people how to do this well. Thirdly, get your reporting right. Start with the end in mind. What action are you trying to drive from that report? And then build the reporting around that. And lastly, don't just track your finishing line. You need to have your finger on the pulse. You need to know as soon as something's slipping, and so you can do something about it. So track as many stages as you can within that part's life cycle.
Good. And I think this is a journey that we're on. I think I explained earlier, it's all come from starting to do this work and figuring out ways to do it more effectively. But just listening to the keynote this morning, Jonathan's keynote with all the data visualization, you suddenly realize how wanting even our reporting, which we think is quite good, how wanting that is and how much further that can go. So we want to keep developing this, and this is one of the areas within complex programs that we see needs, but there are many, many more. So we're very keen to get people's involvement. We've started a series of what we call challenger workshops. So there are lots of people now in businesses which are either very new or that are starting very new things and that are trying to do them in a very different way. So we've got a series of conferences looking at the product data management, the data issues that we tackle and how they can be brought to life in those programs to halve program times and really address them. The next one's on the 14th of May and we'll be in London. So if you're interested in getting involved in that, please put your hand up. And a huge amount of our experience has been in automotive, and we are now starting to do much more outside of it. But we would love to hear from some people, many more people outside of automotive, and how those challenges differ, and what different important points there are. So Thank you very much for listening. Any questions?
So how's the room? What questions do we have? Oh, come on, there must be something else, unless you want to stay until tonight, right? We had that yesterday. My question would be, having been part a whole life on automotive, right? How did you convince OEMs to move from their way of tracking projects, which is mainly something like a little bit Atlassian, and then there's a little bit of Microsoft Project, right? And a lot of Excel spreadsheets, to a more cloud-based, online, data-driven approach? So what is it that makes it click for them?
I think the biggest thing is just the work involved in doing it based on what they're doing. So if somebody's running the Excel model, which is often something we see, there's a lot of work to maintain that and to keep that moving. So even just that investment, the heads you save, starts to fund something more interesting. But it's when you start getting more demands for functionality or for liveness or better reports, it's like, well, we can develop that here for you, but it's actually going to be cheaper to use this thing that we've developed based on all of those experiences that will fulfill those needs. So it actually is a more effective and more efficient way of delivering it, and that's usually what sells it, is the experience of doing it without that, and then bringing that into place.
I think also when projects are late or there's overruns or overspends, often people aren't good at actually quantifying that and actually really measuring how much that's costing them. And when you can show that root cause is back to data quality issues or poor planning, there's quite a convincing story there that if you get this upfront stuff right, it can save you a lot of pain and suffering later on.
The upfront stuff, that's also an interesting one, because I guess most probably you're going to be pulled in when the project is already running and something is wrong, and we need now someone to tell us how we get it back on track. How much time do you need from we going on site until you have some relevant insights for the people working with it?
It's pretty quick. I mean, getting the insights is relatively quick. So it's both the tool and our team are sort of set up to be able to get that data quickly and get an understanding of it. So within a couple of weeks, you'll have a good view of what's going on. But the actions you've got that you can do about it at that stage are pretty limited. So there isn't much time to recover. There isn't much. So you will save days, weeks probably on what the outcome would be otherwise. But that's not much time left. And the biggest challenge we have is getting people to care enough early enough. So the origins of these problems are way back here. We forgot to put this in the bill of materials, and we're not worried here. We've got lots of time to fix it. But the consequences are out here, and they're very expensive and very big, and they feel like they're tied to these, these last events. But actually, they happen back here, and I think that because of that time difference and that focus difference, I think that's why quick release has a role and has a job. And if we could actually make things more visible and be able to say at this stage, this error that you're carrying at the moment is the most likely outcome is that this is going to be the cost of it at the end, then that will be a wonderful report to create to engage people at the really early stage. And it's so much cheaper to fix it then than it is to try to recover it at the end.
And my last question would be about this hardware-software struggle. Right? And that's not only automotive. I think it's coming in under other industries too. But the hardware goes like the V model. It goes down and then it comes up again. And here goes the software that continuously does like this. Is this a problem, or how would you recommend what needs to be done to a product lifecycle management system or process to get over it? Because specifically automotive seems to be struggling.
Yeah. I don't think that we have a good answer for that now. Give us a year and we'll come back and we'll tell you. We do have some insights, so we've done some work on this and on how it integrates within the plan. But I think it's just about the biggest challenge out there. So this kind of getting data quality right, and then working out how software sits alongside hardware are probably the two of the biggest challenges out there, we think. So I don't know, Nick will have more insight than I do. I don't know.
I think it's a very, very tricky thing. I mean, it also drives back to just the way people talk about things and the language people use when you're bringing people from a software world and people from a hardware world together. I think we need to first manage to get people talking to each other in a way that you understand each other. And then from that, we can then drive the processes and the systems supporting it.
Terminology is a big one, right? Because you have a project manager and a scrum master in the same room. Thank you very much. Any more questions from the room? Marcus.
Nick, so obviously kind of what you've presented and kind of developed on, thanks, and developed on BTRS, it represents a fairly traditional design development environment where you've got a clear milestone for delivery. Have you thought about building BTRS Chronos tool out further to deal more with change management situations? Obviously, it's kind of a key theme and kind of topic of this conference is change management, and there are a lot of complexities within all of the industries around kind of how you manage individual part change going into factories.
Yeah, the first kind of step on that is just getting sheer visibility so that you can see in the tool when things have been changed, when you're getting those feeds through from your master bill of material system. So at least you can then know where you are and what needs to be reconsidered. I think there is definitely some challenges around, okay, when you do get that change through, what does that mean for each of those stages? What does that mean for each of those pieces of data? And yeah, it will be a future module coming for Chronos.
Fantastic. Look forward to it.
All right. Thank you very much, gentlemen.
Thank you.
Thank you.